In this video, let's take a look at Target 53, linear programming. Linear programming is a process used by businesses to calculate maximizing profit or maximizing use of resources. The idea behind doing these type of word problems is to look for and set up a certain template. Here's what I like to have students do as they think about doing these questions. Is what you want to look for is, the title is obviously linear programming, but what I put across in green is what are you building or what are you buying, and you put those variables across the top. Just put a shortcut of what they're called. Then the resources you have available go down the side. What are you using to build these resources? What are you using to think about as you buy? Okay, and then the restrictions. What are you restricted by? That's typically a less than or equal to or greater than kind of a statement. Then I have people draw a line, and then you're trying to maximize something, maximize the profit, maximize the volume, or something like that. So then you put an equation down here and solve. So here's what a typical problem looks like. It looks like this one that's in your packet, and it says that the B&W Leather Company wants to add more handmade belts and wallets to its product line. Each belt nets a company, and it just lists a whole bunch of information. So here's what you need to think about. There are two items. It's belts and wallets. So you just immediately put belts and wallets going across the top because that is what you're buying or what you're building. You put those there. Then down the side we need to list our resources. Well, the resources that are available to you are cutting and sewing, because that's what it takes to make the item. So in here it talks about a profit, it talks about required cutting and sewing, and you put those numbers where they line up. There's cutting in belts and cutting in wallets, and we line those up. And then on this side we put the restrictions. They're governed by something, a certain number of hours that are possible. And then I draw a line right here, and I put the information that has to do with the profit below the line, and I make my calculation. So if you were to look at this question, what you'll notice is it says a belt nets $18 profit. So that means each time I'm going to make $18 per belt. We might as well call the belts the X variable. And then the wallets net 12, so plus 12, and we'll call that Y. That'll represent the Y variable as we're building our equations. Okay, so those two facts, I've used those. Both belts and wallets were called cutting and sewing. Belts require 2 hours, so 2 hours of cutting and 6 hours of sewing. I put those on top of each other because that's belts column, cutting and sewing. Okay, so I've done this and this. Next, wallets require 3 hours of cutting and 3 hours of sewing, so that's 3Y in both of those spots. Then it says cutting machines are only available 12 hours a day, so add these together, they have to be less than or equal to 12. Add these together for sewing, it has to be less than or equal to 18, and that's the usual setup. So now we've listed our resources going down the side, what we're buying or building goes across the top, what we're restricted by here, and the profit at the bottom. That's typically how they look, and then we go and put them on a piece of graph paper. Now, one of the things we talked about in class is you can graph really quickly if you use what's called the X and Y intercept method. The X and Y intercept method is where you zero out the other letter and you just graph it. So what you would do is, if I zero out this X, then 3 times what number makes 12? Well, that's 4. So I just go 1, 2, 3, 4, and I put a dot at 4. Then if I zero out the Y, 2 times 6 is 12, so I go 1, 2, 3, 4, 5, 6, and I put a dot at 6. I connect that, and I have my first graph. My second one would be zero out this. Y would be 6, so 5, 6. So here's 6 up here, put a dot, and then zero out the Y. X would be 3, so 1, 2, 3. Connect those, and now I've got my inequality statements. Now these are both less than or equal to, so I would have shaded under both of them, shaded under this one. The double shading is in this area right here. So then that gets me my feasibility region, as it's called. This is the point of intersection, this is this corner, and this one up here. So those 4 corners are the vertices of the feasibility region that I would have to test in my profit equation to see which one maximizes. The coordinates for this corner are 0, 0. So if I sit at 0, 0, that means put 0 in for X and 0 in for Y, I make $0. If I go up, the coordinates for this are 0, 4. So if I put in 0 for X and 4 for Y, so 0 times 18 is 0, 4 times 12 is 48, I'd make $48. Then I have to try to find this point of intersection. This point of intersection, typically if you do these on graph paper, it works out to be a nice looking number. What I mean by do this on graph paper is do something like this, and you'll be able to see exactly where it crosses. And this one I'm going to come back to that in a second. And then this last one is 3, 0. So if I do 3, comma 0 as this bottom corner, so 3, 0, that would yield me $54 profit as my total profit there. And then this point of intersection, and like I said, if you can just see it on graph paper, you can. It actually works out to be 1.5 comma 3 in this case. And so 1.5 comma 3 is the point of intersection. Now a couple ways to figure that out. One is, like I said, just look on your graph paper. Two would be to type them in y equals on your calculator. But in order to do that, you'd have to switch them into y equals form, which I took a second to do that already. If you're confused about that, remember, these were our two equations that we started with, and we had to switch those forms. Well, you just move the 2 over and divide by 3. So if I do that over here, if I move the 2 over and I divide everything by 3, I get this equation. This is the one equation you have to put in. And then the other equation is I would move the 6 over and divide by 3, and you'd get this equation. So that's where those two equations come from, is you're solving for y equals, if you want to do it on your calculator. So you put it in, and you push graph, and I can see that's the same graph that I have. So if I go second calc, hit number 5, enter, 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 the point of intersection is 1.5 comma 3. And so that's the place where they cross each other. And so then if I put 1.5 in, I would, plug that in, get an answer. Now it's a little bit ridiculous to do that because you cannot make 1.5 belts. That's what it stands for. That's impossible. So 1.5 comma 3 gives you $63, and so you're thinking that that's the best answer. But you'd be wrong because that's not possible. Okay? So the best answer would actually be 3, 0 because 3, 0 is possible and it makes you the most money. So they should make 3 belts and 0 wallets to maximize profit. And that's what you need to do as you finish this up. They should make, and then you just list it out, 3 belts and 0 wallets and 0 wallets to maximize profit. To maximize profit. And so all of these type of problems follow this kind of setup. So with that, you should be good.